Since you don't have any questions on the homework, we're going to roll right on through this. Do as much as we can. We talked on Monday about whether angles were terminal or not. And folks kind of figured a better way to think about it this morning. If we were to have, let's see here, 20 degrees and, okay, maybe you couldn't see that. Let's look at these two, 20 degrees and 740 degrees. Are these angles coterminal, not? And I was trying to figure out, because Cynthia wasn't here on Monday to hear the notes, and so I was trying to explain it, and I went, oh, I like that better. I like that explanation better. You guys know that what would I do for this? How would I would draw it, okay? Some of you are like, I'm so over the drawing. I do not want to draw any more spirals. I get that. I'm kind of over the drawing too a little bit. So mathematically, what will we have to do? Here's what I think you should do. If you were to take, it has something to do with the revolutions, correct? And we talked about that on Monday. One complete revolution in terms of degrees is going to be how much? 360 degrees. There's something special about that 360 degrees. So here's what I would try. And if I did my math right, it'll work out. Take the two angles that you're given and subtract them. If the difference of those numbers is 360 or any multiple of 360, then your angles will be coterminal. Okay? Is 720 a multiple of 360? Yeah. I can say 720 divided by 2 is 360. Okay? So if you wanted to figure out if two angles were coterminal, mathematically, we're just adding to the notes from Monday. I guess that's a word, mathematically. Then, find the difference of the given angles. Bless you. Okay, that's the first thing. If the difference is 360 or any multiple of 360, then the angles are coterminal. They are coterminal. Okay? So it's just another, because I understand. As I was going through this, a couple examples with Cynthia, I was like, God, I'm over. I don't want to draw anymore. I'm tired of drawing. At some point, you got to just figure something else out. And this is just what clicked with me this morning. So one more tool in your toolbox. One more different way to think about these coterminal angles. Okay? But if that difference is 360 or any multiple, then those angles are coterminal. Coterminal meaning when you draw it, you see, hey, they end up at the same place. They have the same terminal side. Okay? Questions on that? Great. So let's take this coterminal thing a step farther. Okay? What happens when you are given conditions? To find coterminal angles. Because at some point you're going to be given You are going to be given conditions. So you're going to have constraints that you're going to have to follow, rules that you have to follow. If we're talking 360, how many times can I rotate an angle? Seriously, how many times can I rotate any angle? Just once? If you're not given any conditions, how many times can I rotate an angle? An infinite number. I can rotate it however many times I want to, right? So here's what you're going to do. If you were given an example that said, find all coterminal angles to 45 degrees. What do you think we would do? How could you find all of the coterminal angles to the 45-degree angle? How could you do this? It's all based upon, what did we do earlier? What's the magic number? 360, which represents what? Hold that thought. Hold that thought. 360 represents what, folks? 1 revolution. What would I subtract? From what? You're warm. What could I do? What angle? If I graph 45 degrees, there it is. What other angle is coterminal to that? What would I have to do? Add it. Add it to what? Oh, so if because you're thinking math, I think typically drawing, right? So if I were to draw that angle that Dylan wants to just add 360 to, Dylan's angle is in black, the first one, 45 degrees. My angle is in red. What is the measure of my red angle? How much? Why is it 405? Oh, 360 plus 45, which is 405. Okay, so Wyatt, you're saying, all right, 45 degrees. Another angle that is coterminal is 405 degrees. What's another one? Oh, I can go again. How are you going to get that number? If I add 360 again, what is that number? 765? What's another one? What is it? 1125? He did that in his head. I saw him. Is there a stop? It's what? There is kind of a function thing going on, but I ain't worried about that right now. There is kind of a function thing going on because our common ratio would be, or not ratio, but the common difference would be 360, right? But it would go on and on and on and on. We could keep adding 360, adding 360, adding 360. Now, you guys cool with that? Am I going to find all the coterminal angles? No. No. Anna mentioned something before. She mentioned to do what? Take away. If I were to take away, then where would that take me? Oh, and now we're talking, not a positive rotation, but now we're talking a negative rotation. What's 45 minus 360? Negative 315. I'm going to do that in green because I'm going to the opposite. What's another one? How'd you get negative 675? You subtracted 360 again. And can we keep this process going over and over and over and over again, right? Do you see how You know, why are there conditions given? Why would I give you conditions? Because you don't want to keep going on forever and ever and ever. Because we can, okay? But the coterminal angles, don't forget, you have negative angles. We have positive angles. And this has to do with upward rotations and downward rotations. So if I were to ask you to find all of the coterminal angles for 30 degrees, then you would have to have dot, 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 a number, 30, 60, or 30, 3, 90, and keep going and going and going, and then it would be comma, dot, dot, dot. You'd have to have a series, okay? Does this make sense? Do we want conditions, parameters given or not? Yeah, we want parameters given. Give me some boundaries. Folks, whether you realize it or not, boundaries are good. You think they're not good? Because when your parents say, no, you ain't going. You get mad and you pout, and you just go in your room and you slam your door, right? And then you blow up your phone, right? That's what you do. I know what you do. The boundaries are good. Remember that. You don't like it, you'll get over it. If conditions, you will get over it, or you'll be mad the rest of your life. So go ahead and be mad. Write this down. If conditions are not placed on our coterminal angles, then there will be an infinite number of positive and negative coterminal angles. Okay? If conditions are not placed on our coterminal angles, then there will be an infinite number of positive and negative coterminal angles. So we want conditions. We want those boundaries given. And believe it or not, this is all about the math. Okay? Very simple. It's all about the math. What's our number that's important to us? 360. Or, that's in terms of degrees. If it's not 360 degrees, then what number will be significant? 2 pi. Keep that in mind. Everybody have this. All right. Here we go. I want you to do what this says. I want you to find 2 positive and 2 negative coterminal angles to 20-degree angle. Find 2 positive and 2 negative coterminal angles to 20 degrees. Some of you will straight up just write numbers down. Some of you will show the math. Angles. Where do I start? Where do I start? All right, I'm going to start with my angle that I'm given, which is 20, and I'm going to add who? 360, which gives me 380. How many of you had 380 as your first one? Now, what am I going to do with 380? I might add 360 to it, or if I took 20 and I added 360 twice, is that going to give me the same answer? Why am I putting mine? Why am I listing mine this way? What am I trying to show you? With my math, without having to graph it. how many times it's going to rotate. I'm showing you, I'm totally fine with you going 380 and in your calculator blowing up plus 360 and then write down, what is it, 740? I'm fine with you doing that, but by me writing it this way, this is showing how many revolutions. 2 revolutions. You guys with me, yes or no? Okay. Your silence tells me so much. Thank you. I'm guessing you're with me. Do I have my 2 positive coterminal angles? Now what? Subtract. So I'm going to start with 20 minus 360, which is negative 340, right on. And then if I do the same thing I just did, but I subtract. 20 minus 360 minus 360, what is it? Negative 700. Have I done what it asked me for? How many of you had all 4 of those correct? Facile or difficile? Muy fácil. See? Yeah? All right. You do this one. Find one coterminal angle to 3 pi over 4. And don't tell me you don't know what to do. What number was important to us in the last example? 360 degrees. What's going to be important to us now? Why? Because it's in terms of pi, right? It's in terms of radians. So how many of you found the positive coterminal angle? Hands up. That means the rest of you found the negative one. Did you have to? No. You only had to find one. But what am I going to add this time to 3 pi over 4? I'm going to think 2 pi, but mathematically I've got to change that. Why? I got to have a common denominator. Now you guys know that's going to be 8 pi over 4. We have worked with that unit circle enough now. Do you guys agree? You seeing what I'm doing, yes or no? Okay? Do you see what I'm doing? Okay. Yes. But in the end, Weenie, in the end, what are you going to have to go back and do? I know, but when you get your, what is it, 3 pi over 4 is 135 degrees plus 360. Yeah, I just did that. Okay. In the end, what are you going to have to do with 495? No, it can't be the answer. Why? It is correct. It is equivalent. However, it has to be what? It's got to be in radians. If your problem starts in radians, you want your answer in radians, especially if you're not given any other instructions. But change it back, Anna, and see if you don't get 11 pi over 4. How many of you had 11 pi over 4? Did anybody rotate again to get another one? I know some of you found all 4. Did anybody go back? Could I have found the negative? I could have. Would I have been able to count that wrong? Why? Because it's within the instructions given. As long as I give one coterminal angle, then that is exactly what I want. Did you change it back, Anna? No. All you would have to do is you said you changed it to 135 degrees, right? Okay, and then you added 360, correct? And you got 495, which is correct. Now, just take 495. What conversion factor do I use? Pi over 180. Math bracket, and it's going to give you the right answer. Okay? Cool? You can do it that way. That's fine. Fractions are your friends. We love fractions. Yes, we do. We love fractions. How about you? Here's another one. Cole saw a video this morning that looked like you dancing in the street. I'm just saying. I will show you that video before lunch. Oh. Okay, so now find the negative. Find a negative, not the negative. Find a negative, because there are many. Find a negative coterminal angle of 3 pi over 4. Leave it in terms of radians. What am I going to do to 3 pi over 4? What do I do? Subtract 2 pi, which is 8 pi over 4, which gives us what? Negative 5 pi over 4. How many of you got that as your answer? Whether you converted and then converted again, questions on this? Fossil? All right, so since y'all are a bunch of smarty McFarties, I want you to do this, and you're going to do this one on your own. You may work with someone in front of you or beside you, behind you. 3 pi over 7. I want you to find one positive and one negative coterminal angle. Work together on that. You do that one yourself. All right, tell me what to do here. We got 3 pi over 7. What's our magic fraction? 2 pi, which is? There we go. Do what? Okay. Which is going to give us 17 over pi. Hands up. Awesome. 3 pi over 7 minus. Did you get negative 11 pi over 7? Hold up. Let's see it again. Questions? Why not? Weird. Fractions are your friends. Don't forget that. Decimals are the what? They are the devil. Here's another one. That is good. You should remember that. Okay. All right, let's look at this one. So I want you to follow these parameters. Find an angle between (0 degrees and 360 degrees. That is coterminal with the angle measure of 1465. What do we do? Find an angle between 0 and 360 degrees that's coterminal with the angle measure of 1465. What do we do? Wheels turning. That's all you do. You take 460 and you keep subtracting. All right, so what do we have? 5011. Somebody take 1105 and subtract 365. 735? No. Oh, shoot. Thank you. My fault. 745. And we keep going. When do we stop? Once I get under 360. Bless you. And we got 25. Now, folks, are you going to have to show that on paper? No. For your notes, you need to. You need to see what you've done. However, when you're working these problems on your own, you've got to know what to do. Now, keep in mind, if you were to get this wrong and you don't show your work, I can't give you partial credit, right? You know that. Now, 25 degrees. Does that make sense? Yes. Then I want you to do this one. I don't know what number this is. Thank you. 1,500 degrees. It's coterminal to what angle? And it's between 0 and 360. You do that one. I subtract 360 how many times? 4 times. Hey, is there another way to do this? What? Divide by 360. Folks, if you were to do this, and we know that it is for 24, 14. Your remainder is the angle that it's coterminal. Do you know why subtraction and division are related? I want you to think about this. When you're little, what's the first thing you learn how to do? You learn how to add first. Yes, you learn how to walk. Yes, but mathematical related activities. You learn how to add, and then you learn how to subtract. And then, what do you learn how to do? You learn how to multiply. Do you know what multiplication is? It's fancy addition. And subtraction, division is fancy subtraction. And look, and we just proved that. Okay? Because I took away 4 360s, I divided 360 and I got 4. 60, my remainder will be my coterminal angle. Okay? How many of you had 60 degrees? This is so facile, put that away. All right, so we're going to move on to something a little bit different. No, it doesn't get difficult. Not at all. Nope. Since I'm easily entertained, then I'm going to make sure that you don't have the opportunity to be easily entertained this evening. Quit pouting. I see that. Here we go. So, second part of 3-1. So now let's talk about the length of a circular arc. And this makes complete sense. I really don't know why this is stuck in here in this section, but we're going to talk about the length of a circular arc and the area of a sector. This is geometry, total geometry, okay? And if you will remember, we like to go over this specifically on Ross Adams' birthday. When it's his birthday. It is Pi Day. Very appropriate. What? 3/14, which is March 14th. We don't refer to it as Pi Day, though. We refer to it as Ross Adams' birthday. Or, because it is, it's Ross's birthday. It's also Albert Einstein's birthday, FYI. Yes. Go read the board, because we got all this mathematical information. What? Here we go. Where is the arc? Where is the arc? Think of pi, P-I-E, pi. Where is the arc? It's between the two. Relate it to P-I-E, pi. The arc. You're right. It is there. That is the arc. What's the arc like? It's not the piece. It's the crust. The arc is like the crust of a pie. It is a linear distance. It's a linear distance between one point and another on the edge of the circle. So if you will think of an arc as being the crust, then it's the crust. It's the outside. This will be measured, if it's a linear distance, folks, it'll be measured in inches, meters, centimeters, whatever. Okay? It's a linear distance. If I could literally take a tape measure and measure the crust, I can do that. I can bend it and measure the crust of a pie. So that's the arc of a circle. What then? Yeah, it'll never be negative. Why? Because it's a distance, okay? Or it's a length. Very good. What's the inside? Of a what? Sector, okay? This is the sector of the circle. Arc, crust, sector, make a connection. Arc, crust, sector, there we go, slice. The sector is the slice of pie. Okay? It is the area of the interior piece. And whereas arcs are measured in plain old inches, the area of the sector is going to be measured in what? Inches squared. Meters squared, centimeters squared, dot, dot, dot. Arc, crust, sector, slice. Totally go over this in geometry. Okay, it's all related. Haven't quite figured out how it's related to converting radians to degrees, degrees to radians, and all that good stuff, or coterminal angles. But anyway, all right, now, everybody have this. In geometry, we got a couple of different things going on, okay? In geometry, we always deal in degree measure. Not so much in trig, right? And we would be given a circle with an arc. Let me erase that, my fault. And you would be given this. Let's call this circle C. And we've got this angle ACB. What kind of angle is this? Do you guys remember what it's called? It is an acute angle. That's a good description of it, but do you remember as it's related to the circle? Nope. The little slice, we know the angle. Central angle? Do you remember central angles? The central angle's vertex is at the center, okay? So if this is a central angle, which it is, because the center of the circle is C, then what would the measure of the arc AB be? Not if it's a central angle. Not if it's a central angle. Nope. It's just 60. It's equivalent. It is 60 degrees. If the central angle measure is 60 degrees, then the arc measure is also 60. If it were an inscribed angle, remember an inscribed angle, its vertex is on the edge of the circle. If this were 60, then its intercepted arc would be double, 60 times 2, which is 120. That's totally going back to geometry, okay? But if we were to find the length of the arc, we would do it this way. The length of the arc AB is equal to part of the circumference. That's one way we could find the length of the arc, because circumference measures the distance around the circle. Okay? That's one way we could figure the length. Another way we could find the length of the arc, let's do this. The measure of arc AB, you remember that notation from geometry? The measure of the arc AB is equal to the measure of angle ACB divided by 360 times 2 pi r. Pardon? Not really. Okay. All right. Now, where do these pieces come from? The measure of that arc AB is the measure of the central angle divided by 360 times 2 pi r. So what is the measure of ACB? It would be 60 divided by 360 times 2 pi r. Do I know the radius of this particular circle? I don't know the radius. Can you simplify 60 over 360? What is it? 1/6. Does anybody recognize 2 pi r? It is the circumference. So I want you to look at this. Because Anna, you said, well, that doesn't seem very easy. But if I were to find the circumference and take 1/6 of that distance, would that give me the length of that arc? Yeah. And this is just showing you how this is developed, how we find this measure of that arc. This is finding the measure of the arc. Now, this is all in geometry. What's it going to do in trig? In trig now, we're going to not deal with degrees, but we're going to probably deal with what? Radian measure. Okay, so we're going to deal with radians. Now we're not going to have this nice angle that's 60 degrees, but you may have an angle called theta. And in order to find the length of the arc, let's do this. Arc length is going to be equal to the measure of the arc, the measure of the arc divided by 360 What's the distance around a circle in trig? Oh. What happened to the radius? Look back, look above in your notes. Because circumference is 2 pi r. The radius in a unit circle is 1. So it kind of just, what's 2 pi times 1? 2 pi. So when we're finding the arc length in trig, we're going to have the measure of the arc divided by 360 times 2 pi. What do you think? You think nothing. An area of a sector tomorrow, okay? Everybody working? Questions at all? All right, work.